Hello, today I'm going to show you how to build the QLiteOSD. This is a board that I've designed to fly sport mode, FPV, where you want to have all of the possibilities of the on-screen display, but not needing or wanting the flight controller to pass through. And so I've been wanting to, for quite some time, design an on-screen display that worked with a DJI that would overlay primarily the altitude, my pack voltage, the OSD information about from the GPS, but didn't really want to use a flight controller for that. And so you can get these Wemos D1 minis for very reasonable cost, much cheaper than a flight controller. And the neat feature is it supports Wi-Fi, so you can and it has a lot of memory on it, so you can log GPS flight information as well as put it in Wi-Fi mode and connect to it through an access point to download the log files. And the main board I just designed to stack components that we often use, and I'll talk about the different parts of the board. But your voltage divider, this is your voltage step down, so we can plug right off your normal flight pack. I used the balance tab off of my normal 3-cell in the flight pack. It passes directly and powers the video transmitter from my DJI Vista or the Air unit, and then the voltage step down here, and it's set to drop the voltage from what your input voltage is, 12 volt or 16 volt, whatever it might be, down to 5.5 or 6 volt, and that's what is required, the input. It's optimal for powering the Wemos D1 Mini. So the closer you can get it to the read 6 volt on the output, the more accurate the voltage divider is going to be by default in the firmware. So in this video I'm going to show how to assemble the kit, what it comes with, and how to load the firmware. And in a future video we'll go over how to compile the firmware yourself, make adjustments to it so that you can customize it a little further. Starting with the resistors, this is the 7.5. I recognize it by the light green stripe on there, and this is the 30K. And we will start with those in the board here. And then on the back, just bend the pins out. Make sure it's flush and everything looks fine. We'll solder those in a second. And I just heat the base and the hole, and the solder will just wick around it. Then we're going to trim off the excess wire. The next step is to add the Mini 360 voltage step down. I just start by clipping off 4 of these header pins, and then we'll solder them into the board. After preparing the 4 pins, stick them in with a long pin down, and we'll trim that off after we solder on the Mini 360. Now this is important that you get the arrow direction correct. On the back it shows the way the voltage step down goes, and so you need to match that with the arrow on the board. After placing the Mini 360, then you just solder all the corner pins down by heating the base, then applying the solder. Takes a little bit of a steady hand. These solder pads are kind of small on this board, but it should work. Just touch it. And after we get these pins soldered on top, then we're going to flip it over and solder the bottom. To solder this is just a little awkward, but if you get solder on one pin and then you can level it, that should work. So lift it up and heat it, and then you get it pretty flush Now that one pin will hold it in, and we can do the other 3 pins. Then trim off the long pins off the back. We will now connect the battery, the pack battery, to the pins here to supply the flight pack battery. You can select any power adapter that you like. Personally, I like to use the 3-cell balance lead, so I only use 1 battery on the flight for flight. And if you want to power the video unit and the OSD, you simply plug this onto the flight pack balance lead, and you can see we got the positive and outer negative pin, which gives you the full voltage, and in this case for a 3-cell it would be 12 volts. For best result, pre-tin the end of the wire that's going to go through the hole, and make sure you get the positive with the positive and the negative with the negative correctly, as that's always critical. And I applied solder to the tip before I touched that there. Before going any further, you'll want to set the output voltage of the step down using the dial right here. This is a potentiometer that lets you adjust the output voltage, and so we're going to have to voltmeter that. And I'm just using a really cheap one here, and you'll want to set it to like the 20 up here, DCV, and you can read the voltage. Plug this in, and then we can read the voltage on a couple of the pins. Basically, I'm putting the positive end in the 5-volt positive, and the negative is any of the grounds. But by default, this is going to read about 10 volts, and so we need to dial it down so it will output between 5.5 volts and 6 volts. This will give us the most accurate voltage reading in the OSD. To do this, I use a small flat screwdriver that will fit in the potentiometer, and I find that if you use a Phillips, often it'll just spin in there, but if you get a flat with sharp edges, it'll grab, and turn it all the way to the right. Okay, I've adjusted the dial down, and when I read it now, pins I'm going on, this is on the D6 positive. That should be the 5-volt that comes out of here, and then on there, and when I read it, I'm reading 5.93, so we'll zoom out. And that's between 5.5 and 6 volts, so that'll be perfect. Adding the BMP280, you'll see that the pins are marked on the back side of the board, and you'll need to make sure that you line up the pin labels with what we have on the board here. Get the VCC, etc., and ground. So on this board, on the main board, we only use 4 pins, so we just need to trim off 2 of these with the pins that come with the BMP280. And for this part of the assembly, I like to use a simple breadboard. It just helps you make sure the pins are straight, and line this up so the VCC is on the outside pin and the other 2 will be empty. Okay. When mounting the BMP280, now you put the long pins through the board, so they'll stick out through the bottom. And so do the other pins. At this point, you can just You don't want those long pins, so we just trim them off. Soldering the pins for the Wemos D1 Mini, I use a breadboard as well. That guarantees that they're going to be straight, and it'll prevent the board from leaning. I just put them the distance apart, and then I line them up. Before mounting the Wemos D1 Mini socket pins, I like to add the rest of the header pins for the GPS and out to the video transmitter, and just trim off 3 and then trim off 4. I put these pins, skip a pin, and that lines up for the GPS and the video transmitter. Solder one of these and then level the board. The rest of the pins will be straight. So I'm leveling it right here. Let it cool. That'll hold it. I'll do one of these over here. If you get too much solder, make sure you just keep a clean tip. We should have the pins ready. Okay, these are for the one side. Now we'll do the 2 extra over here. That's for future development. For ease of soldering, I put the pins in the breadboard and then put the board on pins, solder the rest. Leveling it here with 1 pin, let it cool. Now we will put in the socket pins. These are the female headers that the Wemos D1 Mini will mount. I like using these because number one, it gives you height over the rest of the components on the board, so we can stack it. But it also allows you to remove the Wemos D1 Mini, program it, or change it if you ever need to. And make sure you line up the board like the diagram on the board, and then press this in. And we'll have the pins from the Wemos D1 Mini, hold them in the position that they need to be. So make sure everything's flat and flush. There's no gaps at this point. So at this point, we can just turn this over flat. You'll see now the female header pins are poking through the back of the main board, and we will now apply solder to those. And on this, I like to apply solder to 1 or 2 of them, and then I'll use a little vise that I use for soldering. The board assembly here is complete. We are able to load the firmware now. First, I'm going to show how to install the optional Momentary button that will allow you to put the QLiteOSD into Wi-Fi mode. To use the Momentary button, I just clip off 2 of the wires that come off one side, bend them both out flat so it looks like this, and then clip off 2 and then solder 2 wires to the other side, and it doesn't matter which it is, but they have to come off the same side, just like this. Looking at the bottom of the board, you can locate the D3 pin right here. It's immediately below the D2. You got D1, D2, D3. So this right here is the D3 pin, and then here is a ground pin. So for the Wi-Fi button, attach 1 of the 2 wires to each. And this is the button that I put together, basically soldered a wire to each one, and then shrink tubed it. And now I'm going to attach, and it doesn't matter which ones you attach, what color. Just do the D3 in ground. We have the Momentary button installed, and all the pins should be clean now. Make sure there's no solder jumpered between any of the pins, and at this point we will load the software. Before you plug in the device, you need to make sure you've installed the drivers for the Wemos D1 Mini. This board uses the CH340 drivers, and you can do a search on the internet to download those. I like to get them from SparkFun. They're pretty well trusted. They also have them for Mac, Linux, and Windows. Basically, just download the driver software, install it, and you may need to reboot your system for the device driver to show up as a COM port. In Mac, it's going to show up as another device to the USB. Once you have installed them and you can confirm that they're working by plugging it in, you'll get the confirmation audio sound, and that it will then be plugged in. From there, need to go to Github, and you can just search this up, NodeMCU Pyflasher, and it usually comes right up on top, NodeMCU Pyflasher. And from here you go, just get the latest release, and this is the latest one here, and they have it for Mac and Windows. So download the version you're using. I'm using the Windows version. Once you've downloaded this, and then also download the precompiled binary for the QLiteOSD, you'll put those into a directory, and I have it extracted here. This is the binary file that we're going to load on the device. So run the Pyflasher, the NodeMCU, and you'll know that the device is showing up as a COM port when it shows up in this list right here. This is a reload button to refresh if you plugged it in while it was already started. Select that, and then go and select the binary file that you are going to load. This is the one I want to load on here with GPS. And then accept, I think, the rest of the defaults, 1150-200 baud rate, dual I/O, and then no for the erase flash. This right here is the button that you would press to load the firmware. You can watch the output. This is loading the percentage here. Once it is done downloading, I would unplug it, plug it back in, and you should be able to then see the light flashing. So it's done loading. We'll go ahead and unplug this. Plug it back in. And when the light is flashing consistently like this, it's running in OSD mode. It's ready to run. You could then plug in your GPS, plug it into your video transmitter, the DJI, and make sure you have enabled the OSD feature in your goggles so that it'll assemble. And my next video I'll show you how to compile the source code yourself, so you can move things around on the screen. If you don't like where the default locations are, you can turn things off if you're not using GPS and you don't want to see any of that. I'll show you how to remove that. But for this is the default configuration. It supports the Wi-Fi mode, GPS logging, and full GPS. You'll get everything on this OSD right now, excluding the RSSI. Okay. I have mounted QLiteOSD in one of my favorite FPV platforms. It's one of my Stingrays. I've mounted it on the inside here, and up on the outside right here is the DJI Vista unit and want to show you how to put it into Wi-Fi mode. So if you see, I have the Wi-Fi button right here, and GPS, these 4 pins, these 3 pins is power, ground, and transmit out to the Vista unit. So that's on the OSD. So typically before I plug it in and I want to do the Wi-Fi mode, I'll unplug the video transmitter because I don't want the Vista unit to overheat. And so I'll just show what I'll do. So it's not going to be powering the air unit when I go into Wi-Fi mode. So to do this, you'll just power on the OSD like you normally do for a flight. So I have it powered on right here, and you can see the blue light is flashing right down here. That's in OSD mode. It's feeding telemetry information. And now if I press and hold this button right here for 3 seconds, you'll see that the light will go solid. That indicates that it's now in Wi-Fi mode and will show up as an access point. We should be able to see the access point show up in our network. And you can do this from your phone or from your computer. I usually do it from my phone, but I'm going to show it on the computer. It's easier to capture and show. So you will see a QLiteOSD, and then the last 6 digits on the access point that shows up will come from the unique serial number of the Wemos D1 Mini. That way, if you have multiple people or even multiple OSDs that are in Wi-Fi mode, they should have a unique name. You can click on this. I don't want it to connect automatically, but I'm going to go ahead and then click connect. It's going to ask for the password, and for the access point, the code requires an 8-digit password, and the default one in the code is 1 2 3 4 5 6 7 8, and then you would connect. So we're connected now, no internet. We can open up a new tab, and the address for this is going to be 192.168.4.1. That's the IP address that's always going to be assigned to your to the access point. And so when you're connected, you can hit the device IP with that. So when you hit it, it's immediately going to feed back the files that it has logged. And so these are different flights that I've taken, and their file sizes and the date and time stamps. And this also tells you how much used space is left on logging. It'll log forever. It has about 2 megabytes, but each flight is going to be around 20 kilobytes or so. That's probably about an 8 or 9 minute flight. So at this point, you can download one of these, and it's a standard GPX file format. This is flight number 8. Just save it. After opening up Google Earth Pro, you can import the file by going to GPS and then selecting import from file. And then also you can remove the adjust altitude to ground height. If you uncheck this, this will show the altitude of the flight as well. And then click import, and you locate the file wherever you saved it on your computer or your phone, open it, and then it'll import it. Okay. So from here we can do a tilt. We can see zoom in. You can see where we were and also the altitude in relationship with the logging on the device. and delete all files. Basically it just reformats it, and where you can turn off the Wi-Fi right here. So if you notice now, it's flashing again down here, and it's ready to go. We could plug back in the VTX, the video transmitter for the DJI unit, and it's fully functioning. I wanted to show that I also loaded this exact same file onto my phone, and there's lots of applications that can view the GPX file format. It's a standard XML format used by several geo tracking services and applications, including Google Earth. But if I found this one on the Android phone. It's called GeoTracker. It's free. I loaded the file, and you can see here, and you can see the flight. You can even zoom in. It shows you the start and stop point of the tracking, where we landed and took off from, and for the entire flight. And the other cool thing is the statistics tab that you get up here. And if you click on the statistics, it'll show the statistics for the flight. It shows you how many miles you covered in that flight. I covered 4.5 miles just flying around in circles there. And my max speed, I hit 57 miles an hour, the average speed 31. This is a graph right down here. It shows your speed over the entire flight. And then down here, it shows your altitude. Max altitude I hit in that flight was 287 feet above the starting point. It shows the actual altitude from sea level as well. This graph down here shows your altitude over the entire flight and other interesting information about that, and you can switch back and see the map. And this is kind of a useful thing. I really kind of enjoy being able to look at the altitude and statistics of my flight, how far I flew and where I actually covered. And I hope you find it interesting as well.